Hello, I'm Tony Svekar with the Agriculture Research Service in Burns, Oregon, and our research group has been very active in the ecology and management of sagebrush steppe. So of course we believe this has always been an important ecosystem, but with the potential listing of the sage-grouse under the Endangered Species Act, even more attention has come to this relatively dry ecosystem. We think that maintaining a big picture view of the sagebrush steppe is really important. Sometimes there are conflicts between the way we look at landscapes and the way we look at individual sites or patches. To illustrate, sage-grouse are selective and they pick out patches of dense cover, such as the patch I'm standing in right now. But as we go away from the patch, we'll see that the sagebrush thins out and has a much different structure to it. It's really important for us to maintain these entire tracts of sagebrush. If we don't do that, then we lose not just the landscapes, but the patches that we consider really important. We hope this video is useful in framing that way of looking at the sagebrush steppe.
The Great Basin is a diverse and indispensable area of the western United States. Covering more than 190,000 square miles in 6 states, much of this landscape is covered in sagebrush steppe ecosystems. These ecosystems provide an array of critical goods and services that millions of people and thousands of communities rely on for their livelihood. Rural economies depend on the health of these lands as a backbone to sustainable livestock production. Every major stakeholder group in the region realizes the critical role of these landscapes and the critical importance of stemming the loss of the sagebrush steppe.
Sagebrush ecosystem is one of the largest contiguous ecosystems on the North American continent. We often think of this region as a sea of sagebrush and speak generally of its past and present ecology. But in reality, the sagebrush ecosystem has incredible biotic diversity, dramatic climate variability, and a wide range of management issues. Within the Great Basin, there's substantial and growing concern over a number of sagebrush obligate wildlife species. Greater sage-grouse have become the cumulative face of these concerns, and managers and policy personnel across the western United States are feeling incredible pressure to improve habitat conditions for this species. This pressure is increased exponentially in light of a court-ordered 2015 deadline for the U.S. Fish and Wildlife Service to make a decision on whether or not to list the greater sage-grouse under the auspices of the U.S. Endangered Species Act. One of the greatest challenges in improving habitat for sage-grouse and other sagebrush obligate wildlife species in the Great Basin is that habitat conditions for these species are not independent of the ecosystem health, and the integrity of the modern sagebrush ecosystem has been compromised by a variety of natural and human-associated factors. Chief among these concerns are issues related to non-native annual grass invasion and the expansion of native conifer species. Collectively, these species impact over 100 million acres of sagebrush rangeland across the region and present a challenge of unparalleled magnitude for rangeland managers and ecologists. Non-native annual grasses such as cheatgrass and medusa head form a continuous bed of fine fuel which acts to greatly increase fire frequency and also the size of fires in low elevation sagebrush plant communities. Native perennials are not designed to deal with frequent fire at low elevations and are often greatly reduced or completely wiped out, leaving behind a carpet of annual grasses. On the other hand, the lack of fire has allowed for expansion of native conifer populations at higher elevations. These species eventually form dense stands that suppress understory perennial grasses and shrubs. Without active control, both annual grass and conifer expansion eventually leads to loss of habitat for not only sage-grouse, but also other sagebrush obligate wildlife species. So the central challenge facing managers of sage-grouse habitat in the Great Basin is building a management framework that recognizes the importance of species-centric concerns while accurately allocating management effort and resources to fixing the ecosystem problems within which the sage-grouse decline is set.
Land managers in the Great Basin face a host of challenges and threats to the health of the ecosystem, including invasion of exotic annual grasses, altered fire cycles, and juniper encroachment. A complicating factor is that fire can have dramatically different impacts on lower elevations compared to higher elevations in the sagebrush steppe ecosystem. It'll be important to address sage-grouse concerns within an ecosystem management framework. Recognizing the true ecological causes of these problems depends on understanding ecological processes in disrepair.
Well, I think most would agree that if a declining sage-grouse population is primarily a symptom of a larger ecosystem problem, then addressing factors causing ecosystem decline should become the first priority in developing a sage-grouse conservation strategy. But simply saying that we should make solving ecosystem problems a conservation priority is one thing. But how do we go about doing this in a way that not only addresses the needs of the ecosystem, but also the species-specific needs of sage-grouse? Well, I think a logical first step in such a framework starts with a basic model that captures what is currently known about how the ecosystem functions. And when developing such a model, it is important to understand that vegetation not only varies across landscapes with differences in soils and climate, but vegetation also changes over time in any given spot within a landscape in response to factors such as fire, drought, and grazing. For example, at any given spot on the landscape, we could potentially have 4 different plant communities that occur in low elevation Wyoming big sagebrush rangeland. Each one is different in what plants are present and therefore how well it can meet the habitat needs of sage-grouse. Most people would describe healthy sage-grouse habitat as a plant community with an overstory of sagebrush with an understory of perennial bunch grasses and forbs, because this type of plant community has all the vegetation components necessary to meet the year-round habitat needs of sage-grouse. But sagebrush plant communities are dynamic and constantly change in response to a variety of factors. Perhaps the biggest driver of change in the sagebrush ecosystem is fire. And the impact of fire largely depends on fire severity. Low severity fire often removes much of the sagebrush, but leaves a plant community dominated by perennial forbs and bunch grasses that can offer prime brood rearing habitat. On the other hand, a buildup of fuels in more extreme conditions can often result in higher fire severity that not only takes out the sagebrush, but can also kill understory grasses and forbs. This can open the door for invasion by cheatgrass and other exotic annual grasses, often resulting in a non-habitat state as far as sage-grouse are concerned. Fire is not the only factor that causes vegetation to change. If grazing is improperly applied, it can result in a plant community dominated by sagebrush with little understory grasses and forbs. These areas can still offer important wintering habitat for sage-grouse, but are an ecological time bomb waiting to happen. A wildfire in this plant community would likely convert this site into an almost useless annual grassland. Fire, improper grazing, and invasive weeds can be threats to both the ecosystem and sage-grouse. Fortunately, we also have opportunities to intervene with conservation measures to improve the ecological status and associated habitat value of sagebrush rangeland. However, restoration of degraded areas such as exotic annual grasslands is difficult, incredibly expensive, and often fails. Therefore, the obvious conclusion is that conservation objectives must focus first on preventing plant communities from transitioning to undesirable states, and second, to apply conservation measures to move from non-habitat states to plant communities that can serve the habitat needs of sage-grouse. Once we've achieved a desired state, additional measures can be used to reduce threats that are specific to sage-grouse. But focusing on such measures in habitat that is at risk can divert attention and resources from addressing the underlying ecological issues that ultimately define the current and future habitat value to sage-grouse. And ultimately, successful conservation of the ecosystem would benefit not only sage-grouse, but the multitude of other plant and animal species that rely on the sagebrush ecosystem.
Pressures and threats to the sagebrush steppe ecosystem continue to increase. These are vast landscapes, and focusing on maintaining and enhancing the ecosystem is critical to repair ecological processes. An ecosystem management framework can benefit all the goods and services these lands supply, including habitat for sage-grouse. For more information, visit the EOARC website at oregonstate.edu/DEPT/EOARC. The site includes a searchable publications archive, contact information for the scientists who participated in this video, and more.